Okay, so an exponential expression is completely simplified if there are no negative exponents. So one thing that we learned last week is how to make a negative exponent into a positive one. Does anybody want to tell me how you do it? How do you turn a negative exponent into a positive one? What's that? Yeah, make it into a fraction. So if you have x to the negative n, it's going to be 1 over x to the n. Okay, so if you have any negative exponent, okay, it's going to be 1 over and then whatever that power is, but you're going to make it positive. Okay, and then the second one says the same base does not appear more than once in a product or a quotient. What that means is you only have one letter for each base. Okay, so if you had two A's, you would have to combine them into one. If you had two X terms, I'm going to show you how to combine them into one. Okay, and then the next few are different rules that we're going to learn today. So there'll be no powers raised to powers, no products are raised to powers, and no quotients are raised to powers. Okay, so that's what I'm going to show you how to simplify today. Okay, and then the last one, I know this sounds pretty fancy, numerical coefficients in a quotient do not have any common factor other than 1. All that means is if you have two numbers, you have to reduce the fraction. Okay, so all this means is that you have to reduce fractions. Okay, so if you have 3 over 6, that would be 1 over 2. Right? 3 over 6 is 1/2. Okay. So the product of powers property is what we're going to talk about first. If you have two powers with the same base and they're multiplied, okay, so they have to have the same base, you can add their exponents. Okay, now each one of these is going to have a rule, and the rule is always shown with variables. So I'm going to show you what the rule is, and then we're going to do some examples with numbers, okay? So the rule for the product of powers is if you have a to the m power times a to the n, it's going to be a to the power of m plus n. Okay, so if you have the same base, you can add their exponents together. All right, now in this number, which one is the base, the 3 or the 2?
3.
Yep, because what would the 2 be called?
Yes.
Yep, the 2 would be the exponent. Okay, so does the second one have a base of 3 as well? Yep. So if they both have the same base, you are going to add the exponents together. Okay, so this is what it's going to look like. Yep. All right, so then you keep the base the same. So just like with this one, A is the base. Okay. And notice that you keep the base the same. So here, this is the part that people get confused a lot. So if it's the same base, you keep your base as 3, but what you're going to do is you're going to make it 2 plus 5. Okay, so 2 plus 5 is going to be what? 7, so your answer is going to be 3 to the 7th, like this. Okay, and we're just going to write out for this one why that's true. So 3 squared means 3 times 3. If you have 3 to the 5th, that means 3 times 3 times 3 times 3 times 3. So if you multiply these all together, how many do you have all together? 7. Okay, so that's why this rule works. Okay, for part B though, you have 2 different bases. Okay, so one of your bases is 2, the other one is 3. So we're going to do this 2 different times. So I like to underline which bases are the same. Those have a base of 2. And so if they have the same base, you can add their exponents. So this would be 4 plus negative 2. Okay, and 4 plus negative 2 is the same thing as 4 minus 2. Okay, so you would get 2 to the power of 2. Alright, now based on that, I want you guys to do the 3. Okay, so I want you to find 3 to what power? And all you have to do is find the exponent. You don't have to go any further than that. Nice work. So then you guys got 3 to the power of 6. And then what you're going to do is just write them as being multiplied together. So 2 squared times 3 to the 6. Okay, and I saw some of you even went to part C, which is awesome. So when you are dealing with the letters and you're writing them out, the rule is that the letters go in alphabetical order. Okay, so if you have Q and R, the Q is going to go first. Alright, so then for this one, if you look at the Q's, Reagan, what'd you get for that? How many Q's did you end up with? Yeah? Okay, now because there's nothing that nothing else that has the R, you're just going to keep it like this. Q to the 9th times R squared. You can also just write Q to the 9th R squared. Either one of those is fine, whether you put the dot in between or not. Okay, now for part D, you have the same base for all of them. They all have the variable n. Okay, but you can't see an exponent on n. So do you guys remember what it is if you can't see it? No? Not 0. Because if it was 0, that would take this away. Anything to the 0 power would be 1.
It's 1.
It's 1. Yep. So if you don't see an exponent, okay, so if you don't see the exponent, okay, that's when it's 1. Okay, and then we're just going to add all of those together. Okay, so you have n to the power of 3 plus negative 4 plus 1. So we know that 3 plus 1 is what? What's 3 plus 1? 4. So if I have 4 and negative 4, what does that make? 0. So this is n to the 0. Now this is one of our special rules, right? Anything to the 0 power is what? 1. So you would simplify that to 1. because of our special rule. And then the next rule we're going to talk about is the power of a power. So this occurs when you have a power raised to another power. When that happens, you can multiply the exponents. Okay, so if you have a power raised to a power, you can multiply the exponents. So that also has a special rule. Okay, so if you have a to the power of m to the nth power, this is a power to a power, that's when you're going to multiply. Okay, so one thing that I use to help you remember is if you do a power to a power, you only have one base. Whereas when we did this, you had two bases of A. Here you only have one base. That's the power to the power. Okay, so for this one, we're going to raise 5 to the power of 2 times 4. So what is 2 times 4? Yeah, so it'll be 5 to the 8th power. Right? Now, when you multiply anything by 0, when you multiply those together, you get 4 to the 0, and we just reminded ourselves that anything to the 0 power is what? No? 1. Yeah? Good. Okay, so any number raised to the 0 power equals 1. Okay, so that's one of our special rules from last week. Any number to the 0 power is going to be 1. The reason why is because if you multiply anything by 1, you get the same thing. Okay, so it doesn't change the value. Okay, now we're going to see some of these combos. Okay, and those can be a little bit overwhelming at first. So what I like to do is just simplify any powers to a power, because that's going to undo your parentheses. Okay, so if we do 3 times negative 5, do we know what that's going to be? It would be x to the power of, yep. Okay, so we do that, and then we still have the times x to the 4th. Okay, so when you multiply and you have these two bases, that's when you're going to add your exponents. Okay, so if you add the exponents, negative 15 plus 4, let's do that on our calculator. That's likely what you'll be doing, right? Negative 15 plus 4. Whoopsies. What do you get? Yep, good. So you are going to get a negative. Now, one of the first rules we talked about is when you're simplifying, you don't want a negative exponent. So you have to simplify. Okay, so you want no negative exponents. So you have to simplify. Okay, and when you're simplifying, all you have to do is put the 1 on top, and this would be over x to the positive 11. Okay, so that's what we were doing last week. Now for D, we're going to have two different ones that we're going to have to simplify. So the first one is this A, then we're going to simplify this A. Okay? So I'm going to give you a minute to rewrite those based on what we did here. All right, and then Bree, can you tell me what you got for this A power of A? Yep, A to the 12th. Okay, and then Avery, what'd you get for this one? Good. So a negative times a negative is a positive. Okay, so our next step, okay, these are multiplied. Okay, so Erica, can you tell me what we're going to do with the exponents? Or if you're not sure, tell me that too. So if you're multiplying together, this is when you're going to add your two exponents. So we're going to do 12 plus 6. And that's going to give us what? Yeah? 18. Okay, and then if there's no negative exponent, then you're done. Okay, you want to make it so that it's just one variable to one power. Okay? Alright, so the next thing we're going to do is the power of a product. Okay, so if a product is raised to the same power, you can, and what we're going to do is we are going to apply the exponent to each term. Okay, so we're going to apply the exponent to each term, and each term is going to be inside the parentheses. So we're going to write out our rule for that. Okay, so if you have something inside the parentheses that's multiplied and raised to this power, what you can do is you can raise A to the nth power and B to the nth power. Okay, so we're going to do the first row of these together, and then I'm going to let you do some practice. These on the bottom are more complicated, so I'm going to give you some easier practice first before we tackle those, okay? All right, so again, this says simplify. So we're going to distribute that 3 to the 4 and the P. So this is 4 to the third times P to the third. Okay, now 4 to the third, we're going to simplify, and you can do that in your calculator using the caret key. So 4 to the third, okay, and then your final answer is going to be 64p cubed. Okay, now for B, you're going to apply those to two things. Okay, so when you're doing that, think of the number as separate from your variable. So we have -5 to the second power, and then this is t squared to the second power. Okay, so what that means is you're going to do -5 squared, but in parentheses. What is -5 times -5? What happens when you do negative times a negative?
25.
Yep, it should be positive 25. So if you get a negative in your calculator, it's because you didn't do the parentheses. And then this is one of our special rules. If you have a power to a power, what could you do with those? What do you have to do with the 2's? Yeah, multiply them. So 2 times 2 is going to be 4. This is your final answer. Okay. Another way that you can think of these is if you have 4p to the third, that's multiplying 4p times 4p times 4p. So what you're doing is 4 times 4 times 4. That's how you're getting the 64. And then p times p times p, you're adding the 1, the 1, and the 1. P to the first, p to the first, p to the first. So if this is squared, you're doing negative 5t squared times negative 5t squared. So the negative times the negative is a positive. T squared times t squared is going to be t to the 4. Okay, so you could think of them that way as well when you have the numbers. So if you want to think of this as negative 2y times negative 2y times negative 2y, you can. Okay, so negative 2 to the third times y to the third. Now, if you have a negative times a negative, it's a positive. We know negative 2 times negative 2 is 4. What's 4 times negative 2? What's 4 times negative 2? Negative 8. Okay, which is the same thing you get if you raise that to the third power. Okay, it would be the same as if you did negative 2 times negative 2 times negative 2. Okay, and if you like doing it that way, you can as well. Okay? Okay, so we're going to do this first. So we're going to complete the 1 through 18, and that's going to cover up. Okay, so for part B, the negative that's on the outside, if it's not inside the parentheses, we're going to keep it on the outside. Okay, so the negative is just going to stay there, and then the 2y to the negative 3, we want to make that positive, okay? Now, if you have a negative exponent and you want to make it positive, what do you do with it? Make it into a fraction, okay? So the negative drops down, and we're going to put 1 over 2y to the third. Okay, so anytime you have a negative exponent, you want to make it into a positive. So that means you have to put 1 over it, and you're going to do 2y to the third power. Okay, this negative is going to stay on the outside. Now, because this is in parentheses, you're distributing the 2 to both of those. So it's going to be negative 1 over 2 to the third times y to the third. Okay, do we know what 2 to the third is? If not, let's calculate it. Okay, it's 2 times 2 times 2. So what's 2 times 2? 4. 4 times 2? 8. So you have 8y cubed. The negative's going to stay in front. This is your final answer. Okay, so the negative stays in front. It's not part of the parentheses. Okay? And then you apply your exponent. Okay, now I feel like with what we've done before and what you guys have just practiced, that you know what to do with this. What do you do with that 2? You're going to have to apply the 2 to the 6 and the negative 3. So this is a power to a power. This is x to the 6 squared times y to the negative 3 squared. So you have to apply the exponent to both. Now when you apply that exponent, what do you do with the 6 and the 2? Are you adding or multiplying? Multiplying. So 6 times 2 is 12. Negative 3 times 2 is negative 6. Okay, so when you guys were working on this, this is where some of us weren't sure where to go from here. Anytime you have a negative, you have to make it positive. You have to make a positive. The only way to do that is by doing 1 over y to the 6, which this is what we did last week. But now we still have this x to the 12 being multiplied by that. So whenever you're multiplying, remember, you can put a 1 over a value and you can multiply straight across. Okay, so your final answer should have one fraction. X to the 12 times 1 is x to the 12. 1 times y to the 6 is y to the 6. Okay, so this becomes one fraction here. Okay, instead of two values being multiplied together. Alright, now this one gets a little crazy because you have two separate things that you're doing here. So let's take this one first. If you do that to the 4th power. So if you have a power to a power, that's when you multiply. So 2 times 4 is going to be 8. 3 times 4 is going to be 12. Okay, so you're applying the 4 to the 2 and to the 3. Okay, now for this one, you're applying a negative 4. Okay, can you guys write what that should be at the bottom? Okay, so Gabe, what should be my exponent on x for this one? So you should be multiplying the 2 by, the 2 by the negative 4. So you get negative 8. Okay, and then Reagan, what about the y? What should be my exponent on that? Good. Okay, so from here, what you can do is you can combine the like terms. Okay, so you can do that before you make those positive. The next two steps really can be done in any order, but see how you have x to the 8 and x to the negative 8? When you add those together, what's 8 plus negative 8 going to be? 0. And what's x to the 0? 1. So that just simplifies to 1, okay? You're going to end up multiplying that by what you get when you simplify these two together. So here, it's times y to the 12 plus negative 16. Okay, so I know 16 minus 12 is 4, so this is going to be y to the negative 4. But anytime you have a negative, you have to put it over 1 to make it positive. And isn't anything times 1 just itself? So all I'm left with is this, 1 over y to the 4th. Okay, so now you can finish the 19 through 22. And 22 is a scientific notation, which is what we talked about last week.